Hello, welcome to Math with Beth, and I'm going to look at derivatives with natural logs. So, the formula for derivative of ln x is just 1 over x. So again, that seems pretty easy, but again, it helps to see a bunch of different examples to make sure you know how to use it in all of the different situations. So for the first example, if it was just 4 ln x, the derivative would just be 4 times 1 over x, or you could just say 4 over x. For the next example, there's more going on here, so we got to be careful. First, this needs to be handled as a product rule, and then we can just do this part separately at the end. So first, for the product rule here, x squared times the derivative of the derivative of ln x would be 1 over x plus ln x times the derivative of x squared, which would be 2x, then plus the derivative of 5x, which is just 5. We can make that a little nicer because x squared times 1 over x really is just x. Usually the 2x will be written in front of the ln x to make sure you know they're separate, and then plus 5. So that would be the final derivative for this one. For the next one, we now have the chain rule happening because instead of just ln x, we have another function here. So we have a function inside of a function. So chain rule. What is the derivative of ln of something? Well, it's 1 over that thing. But now because of the chain rule, I also need to multiply by the derivative of what we were doing. So that would be 2x. So really at the end, the 2x can just go on top of the x squared minus 5. So the more you do of these, you'll get in the habit of just immediately writing it like that. But at first, if you need to do it step by step, that's fine. For the last one, we could do 1 over all of this and then the derivative of all of this. But here's where our log rules could come in, because first I could just rewrite this by using the log rule that allows me to split this into 2 logs being multiplied. Subtracted. Instead of division, I can subtract log of the top minus log of the bottom. Now I'll do the derivative. So for the derivative, I'm going to do 1 over x to the third plus 4, but then times the derivative of that. So I'm just going to go ahead and put that derivative right on top. Minus, this one is simple, so just 1 over x. So that's how you can handle the chain rule with ln. Now for an application problem. A new book is released and the time t in weeks needed for sales to reach n units is given by this equation. So t is going to be the time in weeks. That's what this is going to be. And n is going to be how many units sold. So for A, the number of books sold means they're asking for the n. After 30 weeks means they're giving us the t. So we can just plug 30 in over here and then see if we can solve this, which is going to be a little tricky. So you might want to try it and see if you need help. So first I can divide by 60. So that really gives me 0.5 over here, equaling ln of all of this. But at this point, we're stuck because we can't move something that's being taken the natural log of. So now we need to rewrite the problem, remembering that ln always means there's a little e here. So we can rewrite it as e raised to that power equaling this stuff. Now we have to think, how would we do the algebra when the n is in the bottom of a fraction? So I'm definitely going to probably move the n first by multiplying both sides by the denominator there. So 400,000 times e to the 0.5. Gonna see what that is. Minus e to the 0.5 times n equals 125,000. Now I can subtract this to the other side. So subtracting that from 125,000 gives me this. So this is just a lot of algebra I'm doing here. Now I can divide both sides by the negative e to the 0.5. And we get 0.6675. So since we're talking about units and books being sold, we'd probably round this to the nearest whole number. So after 30 weeks, they have sold about this many books. So this one was a little tricky as far as the math. We had to get the ln by itself first. Then we had to rewrite the problem with e, then still had to do a bunch of algebra after that. All right, this one should be a little easier because this time it's giving us the n. So all we have to do is plug it in. So plugging in 325,000 for n would look like this. So you still need to be careful on how you put this in the calculator. It's easy to put it in incorrectly. So I'm actually going to do this in the calculator first. 125,000 divided by parenthesis 400,000 minus 325,000. Now I'm going to do the ln of that answer. Then finally times 60. So it's up to you how you want to do it as long as you're getting the right answers. So we get about 30.6 or about 31 weeks. It takes about 31 weeks to sell that many books. That's what the meaning is. So what is the meaning of T 325,000? It is how many weeks it takes to sell that many books. And now for T prime of 325,000. Well, first we need the equation for T prime. So the first thing I'm going to do before I even do the derivative is I'm going to rewrite the problem because again, we can use the log rules to separate this into ln 125 minus ln of the 400,000 minus n. So this is just me rewriting it. And now to take the derivative, the 60 will be out front. The derivative of ln of 125,000, since that's just a number, will be 0. And the derivative of this would be 1 over 400,000 minus n times the derivative of this, which is just -1. So all of that really gives me 60 times 0 is 0. 60 times a -1, but there's also a minus there, really changes all that to plus 60 over 400,000 minus n. So this is the nicest version of the derivative. So now I can go ahead and plug in the 325,000. And I get 0.0008. And what that means is after we sell, once we reach 325,000 units, it is increasing by about 0.0008 weeks per unit. That's the rate of change. Okay, the rate of change when we sell this many units is 0.0008. That's about how many weeks per unit. Okay, so the word problems are a little tricky. It takes some practice, but the more you do them, you'll get the hang of the derivative always meaning the rate of change. So you'll just have to think in terms of the problem, what is it that is changing? And if you have more questions or need more examples of that, feel free to reach out and let me know.